principle wherein which a fixed wing aircraft will go with a certain area of the wing generating the lift. That means based on the velocity and the wing area, it can generate a pressure difference which can support the weight of the aircraft, which is gliding, okay? Wherein which you have a wing which will be generating lift and which will be able to make the flight to happen, which is what we adapt in a fixed wing aircraft. And you can see the efficiency of the glider is based on a mathematical thing called glide ratio, which is the ratio of lift, that means the amount of the lift generated to the drag of the body. You can easily test this one by taking this dart like a body, like a sparrow body. You can make a sparrow body and drop it from 1 meter height. How much it will go in the horizontal direction before hitting the ground, okay? If it is a long distance, means it's a very good glider. For example, what we have, humans also built gliders, which are very efficient, which are very lightweight and have generated a lot of lift, but very little drag, so that it can, for if you drop from 1 meter height, it may go for 8-9 meters. For example, albatross, a sea bird, can go up to 10 meters. If you just drop that albatross stretched wing object, okay, from 1 meter height, it can fly for 10 meters before hitting the ground. It has a glide ratio of 10, okay. You need to have higher glide ratio if you want to use gliding as a means of flight. Go to the next one. Soaring, you might have observed, many of our eagles and vultures, for scavenging the forest area, they use thermals. Thermals means there are hot plumes rising from the thing. They do not take into flight till the sun rises in the horizon and heats the ground. Here and there you get thermals. What they do is that they stretch their wings, sit on these thermals which are rising current, so that they go from one current to other current without expending the energy. They try to do the scavenging. That means they try to do an aerial survey and then identify dead animals or small rat or something. Then they swoop on and then catch. So that they basically try to save their energy using something called air current. Sometimes if there is a hillock, there is a breeze, what will happen is that ಗಾಳಿ ಬಂದು ಗುಡ್ಡಕ್ಕೆ ತಟ್ಟದು ಮೇಲೆ ಹೋಗುತ್ತಲ್ಲ, ಅದ್ರ ಮೇಲ್ಗಡೆ ಹೋಗಿ ಕೂತ್ಕೊಳ್ತವೆ. ತಾವೇನೋ ಕೆಲಸ ಮಾಡೋದಿಲ್ಲ, ಆ ಏರ್ ಗಾಳಿ ಒಳಗಡೆ ಬರುವಂತಹ ಮೂಮೆಂಟ್ ಅನ್ನ ಯೂಸ್ ಮಾಡಿಕೊಂಡು ದೇ ಫ್ಲೈ, so that they can fly for a longer distance and longer time. That's the whole idea. Go to the next one. This has been actually instrumented flight of a bird, indicating energy consumed during the flight by using a gliding as such. You basically soaring and gliding does not consume energy, which is indicated by the red graph at the bottom. But while flapping, you are to rise a location or changing from one thermal to other thermal, they expend the energy. Essentially what I am trying to say is that bird is basically using natural currents which are beneficial for them to keep up in the air, and they do the survey. That's what they do. Okay, that's one method. Next please. This is another one. It's called dynamic soaring. Schematically I shown here. What it does is, if the air is flowing on the ocean, okay, on the ocean air has to come to the rest because water is there. It will have the water velocity, whatever, 1 meter or a half meter per second would be the velocity at the ground. But as you go up, velocity becomes high and high. Okay, do you agree? ಮೇಲ್ಗಡೆ ಹೋದಂಗೆಲ್ಲ ನಿಮಗೆ ವೆಲಾಸಿಟಿ ಜಾಸ್ತಿ ಆಗ್ತದೆ. ಗುಡ್ಡದ ಮೇಲ್ಗಡೆ ಹೋದ್ರೆ ನಿಮಗೆ ಎಫೆಕ್ಟ್ ಆಫ್ ರೆಸಿಸ್ಟೆನ್ಸ್ ಟು ಅರ್ತ್ ಇಸ್ ಲೋ, you will get a higher velocity. Hence there is a difference in velocity from top to bottom. There is a shear that has an energy. Okay, basically this bird basically goes from gliding from the high location to the down, and then come and hit the lower level with the high velocity, travels along the ocean surface, look for the fish, and again goes up in the opposite direction, gain the potential energy, go to the top and keep. This is called dynamic soaring, where the wind velocity is being used to gain height and then keep repeatedly going through it. A small picture is there. You can see this actual bird doing a dynamic soaring, which will basically is not consuming its energy. It is taking energy from the wind and then trying to go from one direction to other direction, scavenging on the ocean surface for the fish and other. Okay, next one. This is one important thing where microwave vehicle and other things we are interested as an engineer is that this particular bird which I showed in the beginning of my slide can fly at one location. Okay. Now the question comes, you have a wing which is moving up and down direction. Okay. What you want, morning he was telling, Newton's law says that you want to remain in the air. You need to push the air down so that you can remain in the air. The momentum transported down should be equal to the weight of the bird or inside. Then it can stay there. Now the question is that you are making the wing to go up and down. How do you are pushing the air only in the downward direction is one question. Okay, that's one thing which I will touch upon little bit detail today. ನಿಮಗೆ ಅರ್ಥ ಆಯ್ತಾ ನಾನು ಪ್ರಶ್ನೆ ಕೇಳ್ತಾ ಇರೋದು? ವಿಂಗ್ ಬಂದು ಮೇಲೆ ಕೆಳಗೆ ಎರಡೂ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಮೂವ್ ಆಗ್ತಾ ಇದೆ. ಬಟ್ ಬರ್ಡ್ಗೆ ಏನ್ ಬೇಕಾಗಿದೆ ಅಂತಂದ್ರೆ ಬರೇ ಗಾಳಿನ ಕೆಳಗೆ ದಬ್ಬಬೇಕು, ತಾನು ಮೇಲೆ ಉಳ್ಕೋಬೇಕು. ನ್ಯೂಟನ್ ಲಾ ಪ್ರಕಾರ ನೀವು ಗಾಳಿನ ಕೆಳಗೆ ದಬ್ಬೋದ್ರಿಂದ ಮೊಮೆಂಟಮ್ ಚೇಂಜ್ ಆಗುತ್ತೆ. ಆ ಮೊಮೆಂಟಮ್ ಚೇಂಜ್ will produce a force that can support the weight of the bird. Am I right? But the question is that how do you do that in a reciprocating? In the case of if you have a fan or something, it can push the air down continuously in a rotator like helicopter kind of thing, you can understand. But with bird it is doing back and forth motion. Now somehow you have to make sure air goes only in the one direction. For that I just give you a small demonstration here. Okay. See this one, if you move in one direction, it is stuck.
ಬಸ್ ಎಫೆಕ್ಟ್
ಈ ತರ ಮೂವ್ ಮಾಡಿದ್ರೆ the direction indicates that if I am moving in one direction, it will rotate in one direction. Now the question is, bird has to do something, do back and forth motion, but the direction of this guy should not change. That's the question. What they do is that they move their wing in 8 shape, okay, and generate a force always normal to the wing. That is done by like this. Okay, now I am, even though doing my wing back and forth motion, always the fan is rotating in only one direction. That means always it is going normal to this, rotating this guy means producing the force normal to this surface. That is the motion what the bird will do, hummingbird or anything. Okay, basically you have a reciprocating motion. If I do just this way, one direction you push the fluid down, other direction you push the fluid up, that's not going to be helpful for me. Only way is to move it in a direction in a way that it only pushes the thing down so that I can get a lift. Okay. Apart from that, they also use many other tricks like delayed stall. These are all dynamic effect which I don't get into it. Okay. There are many other fluid dynamical things which happens which will essentially increase its lift generation capacity. Okay. What I'm trying to say is that they are more efficient, they are more clever. If we want to use it, we want to do a biomimetics, that means we want to capture or copy the nature, we need to do many of the things. Go to the next one. Okay, in our thing what we said is, we wanted to establish, if you want, as you were telling, engineer what we want to understand the nature, want to extract useful part and then use it for our technology. That's what we would like to do. First you have to understand, that's the important thing. What are the limitations, where we can apply, how much it generates, all these things we have to understand. Then extract that and then use it for our useful purpose. For that we basically try to understand how a wing motion generates a force and how that can be related. I don't again get into the detail, I just show some pictures and other things to convince that that's what we do, that's what we get an understanding which will be useful for engineering business. Okay, next slide. Okay, as I said, wing kinematics. Wing kinematics means how I move the wing, with respect to that how I am generating the force. That is the relation between kinematics. That means I don't know how I expend energy to move the wing, but I would like to know this kind of a wing motion will generate that kind of a force. Relation between the motion of the wing to the force generation. For that we basically built a small setup which you can do it in your institute also. It's a tank in which we have a water, we have a flapper, mechanical flapper which will generate the flapping motion. We do the flow visualization, go to the next slide. We do the flow visualization. suggestion, we make the wing to move in a particular direction by putting a stepper motor or a motor controller, even your DC motors, whatever you have in your tape recorder or something can be used. Okay, you can build a wing on different shapes of the wing, and doing flow generation we need to put some dye streaks and other things. Okay, these are some details, and we put particles. Go to the next slide. Yeah, we use light to illuminate a particular plane and see how the flow is generated. Go to the next one. I'll just show you some pictures to make sure you appreciate what is going on in the when we move the wing. One of the questions we asked is if the wing is moved, one is moving the wing in 8 shape, okay, which you can generate the lift was what I said. If you have only 2D motion possible, that means I can only move my wing. For example, if you see eagle or a vulture, they only move in this direction, right? But when you move the wing in this direction, the same question, can you make the flow to go in only one direction? That means when I push the fluid down, I will be getting a force which will support my weight. But when I move my wing up, I should not push the fluid up so that I get a negative force which will drive me down. That should not happen. How to generate is the question. Hence what we did was, we considered two kinematics. What is the two kinematics? In which one, I move my wing up and down with the same velocity or same time period. The time period for going down is same as time coming up, time for coming up. I call it a symmetric flapping. Okay? Like a sine curve going up and down. But in another case, I go down little fast, come up slowly. Okay? I am introducing a small asymmetry.